Okay, question number 3 of AP Physics 1 2024 actual exam. The left end of a uniform beam of mass m and length L is attached to a wall by a hinge as shown in figure 1. One end of a string with negligible mass is attached to the right end of the beam. Okay, the other end of the string is attached to the wall above the hinge at point 1. The beam remains horizontal and the hinge exerts a force on the beam of magnitude Fh, and the angle between the beam and the string is θ1. They are saying that the hinge exerts a force on the beam of magnitude Fh. Okay, wait, we are not given the direction, is it? Okay, all right. The following rectangle represents a beam in figure 1. On the rectangle, draw and label the forces, not components exerted on the beam. Draw each force as a distinct arrow. Okay. So we know that there will be a tension at this angle. So we are just going to draw a dotted line at θ1 and indicate that there will be a tension. Let's call it Ft over here. This hinge is of uniform beam. The beam is uniform of mass m and length L. So there will be an mg which is exactly at the center because that's uniform. So that's going to be mg, which is at a distance of L over 2 from either sides. Finally, we have the force of the hinge. So for the hinge, actually we do not know where it is directed because, okay, there is a tension force and the tension force has a component on the top and the left, and there is a gravity downwards. Maybe these two forces cancel each other, maybe they do not, because ultimately I want everything to be cancelled because the beam remains horizontal, so the net force should be 0. And definitely there should be a hinge force to the right because there is no other force to counteract the left force of the tension. So uh, to be on the safe side, what I'm going to do is I'm going to make the FH like this. And I'm going to say that there is some angle which we do not know. Maybe this angle is actually 0, so that FH is horizontal, which we will come to know after solving. But definitely it is not vertical, that is for sure, because it needs something, it needs to have a right component to counteract this left side. So I'll draw an oblique force like this, and the angle will be determined accordingly. Okay, the next question talks about now the string has been moved downwards at point 2 and is connected again to one end of the rod with a smaller angle. So they are saying that now the tension is Ft2. Earlier the tension was Ft1. So compare. I think we can use the concept of net torque equal to 0, right? If the net torque about, in fact, this point, because we don't know the force of the hinge, neither we are interested. The only torque, the only clockwise torque being provided is by mg, which is same, and the torque provided by the tension is the other torque which is going to counter this. The torque provided by, and we have to give a qualitative reason beyond referencing the equations. I'm just writing equations so that I can explain, and then we'll write in the statement. That will be force of tension times the length of the the rod times sine of theta. So now we can clearly see that if the theta is increased and the same torque needs to be maintained, Ft has to increase. So we are going to say that the new torque is going to be greater than Ft1, since due to decrease, since when the angle decreases, when theta decreases, when the theta decreases, uh, L or Ft must increase to maintain the same torque and keep the system in equilibrium. That's what we're going to say. Stating with Newton's second law in rotational form, derive an expression for the magnitude of the tension in the string. Express your answer in terms of m theta, and this begins your derivation by writing fundamental physics principle or an equation. So we are going to say that the net torque is going to be 0. That's Newton's second law in rotational form. Newton's second law in rotational form is net torque is equal to I alpha, right? And since the system is not moving anywhere, alpha is 0, which means that net torque has to be 0, which means that torque due to weight minus torque due to tension should be 0, which means that torque due to weight should be equal to torque due to tension. The torque due to the weight force is exerting exactly at the center, so that will be R is L over 2, F is this, and sine of 90. And likewise, the tension is going to be Ft times L times sine of the angle between it. So that's going to be L, and L is gone, by the way. So that will be mg over 2 because sine 90 is 1. And this is Ft sine theta. And finally, if we divide both sides with sine theta, so Ft is going to be mg over 2 sine theta will be Ft, which means that Ft is going to be mg over 2 times cosec theta. You could have left it as over sine theta as well. That is also entirely correct. Okay, is your derived equation in part C consistent with your justification in part B? What was part B? Yeah, it is consistent, right? Because that's what we thought that. In fact, in a way, I explained using the same equation, but yeah, it is consistent because we can just borrow this and explain. Uh, because of the decrease of theta, we can clearly see that sine theta also decreases. So as per this equation, Ft must increase, which is what we wrote in part B. So yes, it is consistent. All right. So this question talks about if the string is now cut and the beam begins to rotate, draw the omega versus time curve before it becomes vertical. Okay. So I think before it becomes vertical, at some point, it will become in this fashion, and alpha is still here, and this is mg, and it will start making some angle, right, um, with the hinge, right? Let's say this angle is beta. We know that torque is equal to I alpha. So alpha is proportional to torque because obviously the moment of inertia is constant. So alpha is proportional to torque, and in torque there is Rf sine theta. Only theta is changing. So can we say that alpha is proportional to sine of beta? Beta is increasing and increasing from 90 degrees, right? Because initially it was 90 degrees. So eventually, when it entirely becomes flat, the beta will become 180 and sine 180 will become 0. So can we say that alpha is decreasing with time? Right? It makes sense because when initially beta is 90, alpha was maximum, and then finally beta will become 180 and alpha will become 0. So alpha is decreasing with time. And omega versus t curve, and what is the slope of omega and time? Because we know that alpha is nothing but change in omega over change of time. So the slope of omega versus time is alpha, right? So it starts from 0, and when it becomes vertical, there is no torque because sine of 180 is 0. So no torque means alpha is 0. So excuse me, omega becomes constant. So it increases like this with a decreasing slope, because like I said, slope is alpha and alpha is decreasing with time. So this should also decrease with time. So you can clearly see that it is a little bit, concave down kind of, or maybe you can think of it like this. Here, whatever the slope is, here it has to be a little less slope. So it will tilt and eventually it will become kind of a constant, because now it becomes like a vertical, horizontal tangent, because that's where it reaches it, the rod becomes vertical. So that's how it looks like. Now this makes sense. If you have any doubts, please post it in the comment section, and I'll see you in the next video. Bye bye.